Hello, my lovely warriors. Hi, Kamav, Note, GLD, Shruti. Welcome aboard to We Enlite. This is Shreyas here, your physics master teacher. Namaskar, Wanakam, welcome, Ola, Bonjour, Sat Shri Akal, Marhaba. Nice to see all of you, all my lovely warriors, in today's current electricity session with me, Shreyas, your physics master teacher, and you are watching the Zero to Superhero series for both JEE and NEET students who want to ace their examination this year. And these are one-shot lectures which you're going to study with me. And if you want to know more about me, definitely can go ahead and follow me on Instagram. You can see and interact with me over there as well. And before we begin, you know what to do. Go ahead, smash the like and the subscribe button. And do not forget to join the Telegram group link, which is also there in the description box below. I can just show that to you. That's me. And you're watching the video. So hit on more and you will see right over here. There are lots of links, etc. like the crash course link for JEE NEET in English medium. You can also see this is a Telegram channel link. All right. So everything has been mentioned here. And if you go on our channel, there are extensive playlists for almost all the chapters that you can see. And I would love to see you in the crash course as well. Hello, Sri Sanath, Shruti, Nisha. Hello, Darshini, Ritesh. Welcome, welcome. Good evening, Nakshatra. I hope you guys were able to solve yesterday's question. And in case you're wondering where you can get it, well, let me just show that to you, maybe right over here. So you just go to playlist. And you will just see over here Zero to Superhero Physics. So you can just click on this. So all my lectures are available right now as well. And where is it? Okay, looks like it has not yet been added. Maybe I'll add it later on. Sorry guys, but you can even go to videos, and in videos you can see electrostatics has been done yesterday, and I had given you one homework question, and I can see some of you probably would have tried answering it. And thank you all the lovely students out here who have posted all these amazing comments regarding the series and what you want and what you love and how you're enjoying it. Thank you so much, all these students. Means a lot. Vaishnavi, I'm very good. Thank you so much, Bacha. Okay, so let's begin with the class, I guess. And yeah, there you go. And let's start. Thank you so much. Good evening, NEET aspirant. So I hope you guys are now focusing your time on JEE and NEET preparation. Even though if you have maths or biology exam, it doesn't matter. You have time. You have to prepare a lot for JEE and NEET, because JEE is just barely a month away, not even a month. And remember, NEET exam is barely 1.5 months away. Okay, so we need to buckle up. So let's begin. Hi Srivedya, hi Kamanut. Let's begin with the class, and let me just pause this video for now. Okay, so let's begin. Now, like we always do, we'll first start with, the mind map. I will discuss all the pointers around current, electricity and capacitors, because many things are related in this chapter. And then we will, once we are done with the questions, we'll solve some previous year questions and examples right now, right over here. Okay, so let's begin with the class. Ready? And I hope you guys have smashed the like button. In case you haven't, please do that right now. First of all, let's talk about the basic characteristic, parameters, the physical quantities associated with a conductor. So we are going to current, electricity first. So when you have a conductor, you will see that the free electrons move randomly. Okay, they move randomly when there is no field. Their average velocity is 0 without any field from outside. When there is no field from outside. But the moment you apply some electric field, remember, electric field is created when you create potential difference. So there is high voltage here and there is low voltage here. You will notice that these same electrons will start moving. They will start moving towards one side. So what they do is basically they start drifting. So they will start drifting with some speed. That speed is called as drift speed. I'll put VD over here. That is called as the drift velocity, the speed with which they move. These velocities with which they go around like this, hitting around all the other nuclei and the electrons, is very huge, 10 to the power 6 meters per second. The drift speed, so while they are hitting like this, slowly they are moving. slowly they are moving ahead. That speed is very, very small, typically in micro or millimeters per second. Now, because of that, because of the charges moving, the flow of charges is basically the current. So the flow of the charges per unit time is nothing but your current, and hence I call current as dq by dt. If you want to find current, you can also do this from this equation. Current is the rate of change of charge, so q will be nothing but integral of current with respect to time. I hope you remember this. So drifting is basically slowly getting carried away. You're drifting slowly. You suddenly get drifted in your thoughts. You're suddenly thinking about something, then something, then something. Drift. So electrons were moving, colliding here. Slowly, because of the field, they slowly get drifted. Slowly they start moving in that conductor. That is called as drift. I hope that is fine, Nisha. Bobby, yeah, oh my god, long time no see, Bobby. Nice to see you. And Satya Nadella is also here from Windows. Are you peeping out of the window, Satya Nadella? Hi, John Chelia. What names, guys, you guys have. Crazy. And your pictures are also very nice. But you can also put up a picture of V Warriors, the Ninja Warriors display picture is there. Okay, so make sure you put that up also. Yeah, Wheatstone also will be doing. Around 1.5 to 2 hours. I don't know. Okay, it's going to be 1.5 to 2 hours. Yes, I do know Kumar Pushpam sir. Obviously, I know all the physics teachers, bacha. All right. So now let's move ahead. We have spoken about charge, everything. Now we will also talk about another quantity called as, wait, let me just put it up over here. So if the current is going like this, how much current is going in this much area, in this area? So that quantity is called as the density of the current, J vector. It's always in the direction of the current. This is called as the current density, how closely the current is packed while it is moving in the conductor. Lot of current goes through small area, huge current density. So J is I by A, but if you rearrange it, current is J vector dot area vector. So this is how you can also write it down as J is I by A, I is J into A. Obviously, the unit of current density will be ampere per meter square. Okay, something which you should be very well aware of. Fair enough. So we have spoken about current, we have spoken about current density. There's only one more thing which is remaining, and that is basically your drift velocity. So drift velocity can also be calculated via a formula. I'll just share that with you. And this formula is basically NVIDIA. So current is related to drift speed with this formula, NVIDIA. NVIDIA. Now, if you are wondering what is that N, what is those other things, let me tell that to you. So VD is drift speed. E is basically your 1.6 into 10 to the power minus 19. A is your area, of course. I is your current, of course. This is nothing but number of your charge carriers, per unit volume. That means in 1 meter cube, how many number of charges are there? That's what it is. So if there are more electrons available in 1 unit volume, more charge carriers are there in that conductor. That's what. So should I use negative for E? Well, if you put it as negative, you'll get current as negative. So actually you put a modulus symbol over here. I'm just interested in the magnitude of the current. Okay, we're not exactly interested in the direction, because we already know current goes from higher potential to lower potential. Yeah, there is a crash course starting. No, there is no new crash course, Bobby. The same old crash course is there. But let me tell you, even if you watch the lectures in the recorded form, it is actually good only because now you don't have so much of time. Because think about it, you'll only watch those parts which are important for you. So it's better, in fact, if you watch it in the recorded form. You can even speed up the process. So I would advise you, make sure that you watch even the recorded classes. That's okay. Even if you are getting a live class, no problem. Watch it recorded if you want to. That will be better, especially in the last few days. Okay. One last thing over here before we cut out to the next topic, and that is called as the mobility. Mobility tells you how mobile these charges are, how easily they can flow, and that is given by, so the mobility tells you the ease of the flow of the charges when you apply some voltage difference. So that mobility mu is the drift velocity per electric field. So that is basically the mobility of the charge carriers. Keep this in mind. Is this clear, guys? So all these things are very, very, very important. Okay, shall we move on? Okay, let's talk about the next pointer. And the next pointer is basically your resistance, and then we'll go to capacitance also, don't worry. So if you take a conductor again like this, if the length is L, the area of cross section is A, there is a material property. The material property of that conductor is basically called as rho, which is nothing but resistivity. Resistivity is the material characteristic. So aluminum, copper, wood, etc. they have different resistivities. It tells you whether it is conductive or whether it is resistive. So if the rho is large, it is very large resistance. It will not allow the current. In fact, this rho is exactly 1 by sigma, where sigma is just called as the conductivity of the material. More conductive, less resistance. Less conductive, more resistance. So reciprocal of each other. Now the resistance of such a conductor is given by rho L by A, and it's proportional to length, inversely proportional to area. Sometimes you might need to use this formula as well. Instead of area, you can write it as the volume of the conductor divided by length. So it will become rho L square divided by V. If you're wondering what this V is, it's nothing but the volume. This is not voltage, it's the volume of the conductor. Why you might need to use this? I hope you remember there are questions where you stretch a rod or you compress a conductor. So what happens to the new resistance? So when you stretch or compress something, volume remains the same, because when you increase the length, area reduces. When you compress something, length reduces, area increases. I hope that is okay. Hi Pranav, hi Yogesh, welcome. Hello Arvandan, welcome Bacha. So Barinandan, you can score full marks also after watching YouTube lectures. There have been toppers from our channel. Last year only, you would see that so many students had scored below 1000 rank in JEE Advanced, not even mains, Advanced. So it's all up to your willpower, your hard work and your motivation. Okay, thank you Rose so much. Hello Mohammad Hassan. Okay, let's move on now. Next concept that you should also remember is regarding the effect of temperature. Resistance depends on length, resistivity, area, also temperature. So the temperature dependence is given something like this. I can write the resistance at any temperature T is the resistance at a standard temperature into 1 plus alpha delta T. If you're wondering what this alpha is, it is nothing but the coefficient of thermal resistance. Coefficient of thermal resistance. Is this formula ringing a bell in your head? Is it resembling something which you already know in some other chapter? This is your change in temperature. Change in temperature. This is your standard resistance at usually 0 degrees. Initial one at usually 0 degrees Celsius. This is your final temperature. Coefficient of thermal. Hi Jamesburg, nice to see you back. Full Josh Barinandar, very good. Hi the JEE aspirant. Yes, it is from thermal properties, Bobby, very good. The final length is initial length into 1 plus alpha delta T. The alpha symbol is same, but the value is different. Here it is thermal resistance, there it was coefficient of linear expansion. So that's something which you should be well aware of. Is alpha going to be positive or negative? Think about it and answer in the chat box. Is the value of alpha going to be positive or is it going to be negative? Come on, is alpha going to be positive or negative? Figure this out, then we'll move to the next part. Okay, screen is blurred. Mohammed, do one thing, just go to the settings on the right side, choose advanced and make sure you choose the screen resolution as 480p at least or 720p. No guys, most of you are wrong. Alpha can be positive and it is for conductors. Yes, for conductors it is positive, but it can also be negative for semiconductors. For semiconductors, keep this in mind. You just studied, when you increase the temperature, electrons go from valence to the conduction band, conductivity increases, so resistance drops. So alpha will be negative for semiconductors, but only for conductors alpha is positive, because when you increase the temperature, the motion increases, and because of that the collisions increase, and you will see that their resistive nature will also increase. Keep this in mind. Hema, you want some assignments? Well, assignments is already there in the crash course. There are beautifully crafted assignments for every chapter. Lots of questions which will keep you busy. So there is a link in the description box. There is a crash course link. In that crash course you get for not just physics, chemistry, every subject, all the assignments, JEE level if you join the JEE crash course, NEET level for NEET crash course. Beautiful questions. Trust me, you need to solve these questions. Just giving 4-5 questions is not enough. When you get these questions and you day in day out practice these questions, there is no chance you can get anything wrong, or you would not know how to solve this question in JEE mains exam. Now, moving on to the next one, and that is basically your Ohm's law. Now, you might ignore this topic, but sometimes it becomes very crucial. So in Ohm's law, when you draw the graph of current versus the applied voltage, you will see the graph is a straight line only for a certain device which is called as a ohmic device. So in ohmic device, you will see that the current is proportional to the voltage, which will give you V is equal to I times of the resistance. This is only for ohmic devices which are linearly dependent on the voltage and the current. You might think that, oh, is it possible that the graph can be non-linear? The answer lies right over here. You have studied semiconductors are those devices where the graph for voltage and current is non-linear. So you would see that the graph goes either like this, like this. These are non-ohmic devices. Non-ohmic devices, and semiconductors are one such example, but you can have many more such devices where the voltage and the current are not proportional to each other. Is that understood? Okay, clear guys? No problem. The new session, I'm not sure. New session for crash course will not start. Okay. Now, yes, I taught this topic in detail. Now, there is another modified form of this equation, V is equal to IR, and that is also very useful many times. You need to rewrite this equation in their more specific terms, as in current is the current flowing through the conductor, but the current per unit area, well, that's something which we know, which is current density. So instead of I can write J. Resistance is the total resistance of the conductor, but the more specific property is resistivity. So I can put rho over here. Voltage is the total voltage difference between the points of the conductor, but the voltage difference per unit length, dV by dr, that's electric field. So this becomes electric field over here. And this is also a very important formula. In fact, this is a vector equation. E is equal to rho J or J rho. J is a vector, E is a vector, rho is a scalar quantity. It's a resistivity. So the direction of J is also the direction of the field inside the conductor. Very, very important equation, useful for solving many things. So from this equation, you can also relate it to this equation, and this equation is related to even this equation. So you can see this, and this, and this, everything is related. Even this is related to this. So all these formulas should definitely run inside your head. Cool. Let's move on now to capacitors. So talking about capacitors, capacitors are nothing but energy storing devices. Energy storing devices, and these devices are basically nothing but conductors. So the energy is stored in the field of charged conductors. Keep this in mind. So you charge conductors, there is a field. In that field, you will see that the energy will be stored. So imagine that I have a conductor which is positively charged and another conductor which is negatively charged. Here there is plus Q, here there is minus Q, and I see that there is electric field between them. So let's say the potential difference between them is V. Then I define a quantity called as capacitance given like this. Q is equal to CV. This C is basically called as the capacitance of that device. This is having the unit of farad. 1 farad is when you store 1 coulomb of charge across a potential difference of 1 volt. Now, if you notice, the charges are always equal and opposite, number 1. Number 2, the net charge on the capacitor is always 0, if you think about it, because plus and minus equal amounts cancel, but do not think if the total charge is 0, it has not stored any charge. Those charges are separated, so plus and minus are separated. That's the reason why the field is created. That's the reason why the energy is stored between the plates of a capacitor or between the two conductors. Keep this in mind. Very important. Okay, so Jamesburg, is it better to master some chapters or have some knowledge on every chapter to get at least 100 marks in NEET physics? It's better to master some chapters for 100 marks. Actually, 100 is a good score, bacha, decent enough score. So I would prefer more on the mastering some chapters. But in fact, not some, it will be many chapters. 100 marks. Yeah. I'm so glad, Prachi, and I'm so glad that you are enjoying these sessions. Hi, Namikaze, welcome aboard. Next thing which you should know is that the capacitance depends on the following quantities, and it depends on basically the geometry of the capacitor. It also depends on the shape of the capacitor. It also depends on one more thing, and that is basically your material, what you fill between the plates. So it also depends on the material, basically the dielectric medium between them. So material as in K, this is your dielectric constant. And when you add anything inside, completely fill it, you will see that the new capacitance is K times the old capacitance, where you fill it completely with this medium. So when you fill this completely, the space between the two plates, anything, it always increases K times. If you put a material of constant 5, it will increase 5 times. Very, very important. Now, having said this about the capacitance, let's also talk about geometry and shape. There are 3 major types and a subcategory, which is your 4th type. Let's talk about that as well. So first of all, you have something called as the parallel plate capacitor. The value of the capacitance is given by epsilon naught area by D. A is the area, D is the distance between them. That's the capacitance of a parallel plate capacitor. Next important thing is basically your cylindrical type of capacitor. So you have a cylinder, something like this, say, and the capacitance of that is given by 2 pi epsilon naught. The height of the cylinder is, let's say, h. This is your h, the height of the cylinder, divided by log of b by a. B and a are your outer radius and inner radius respectively. Bigger number by smaller number. That's how you remember it. Last type is basically your spherical type of capacitor. This is inner radius, this is outer radius. The capacitance is given by 4 pi epsilon naught 1 by a minus 1 by b. Very, very important. Now there is a special type of capacitor you might have heard of, and that is called as a isolated capacitor. Isolated capacitor. Yes, we get this. This is a one-shot series. Muhammad epsilon comes when you derive it. Yeah, that's when you derive. Marhaba, Yogesh. So isolated capacitor is basically only one sphere. This is isolated. No other plate isolated. No other plate or no other conductor is there. This has some radius r. You will see that even this stores charges. So even that has a capacitance, and that is given by just 4 pi epsilon naught into radius. This is also a very critical type of capacitor. Good evening, Amrita. Okay, now going ahead to the next part, you will also see that there is a field between the plates, especially for parallel plate. You get these formulas which are very, very important. The field between the plates, every time I've seen students making a mistake. So the field between the plates, E, is given by, you will have Q by A epsilon naught. That's it, nothing else. There is no 2 over here. That's the field between the plates of a capacitor. So imagine there could be a question where you put an electron between the plates or a proton between the plates. find the force on that charge, you will take the field and multiply it with the charge. Everybody with me? Everybody with me? Very good. Vishnu, I'm not sure. Maybe I think you are vibrating. It's relative. Remember, motion is always relative. So maybe you are vibrating. That's why you're seeing everybody vibrating out there. Okay. Last thing, force between the plates. Force between the plates. This is different. This is positive, this is negative. Positive, negative will attract. That force is given by, the formula looks similar, but many people get confused. There is Q square because force will have charge into charge. Field only has charge in the numerator. Divided by, here you have 2 and A and epsilon naught. So the 2 comes in the force. You can remember it that way. If there is a 2 on the top, there is 2 below. If there is no 2, if there is 1, there is 1 over here. That's how I generally remember it. Yeah. Is that clear, bacha? So Shruti, if you're wondering how the introduction of a dielectric increases the capacitance, the logic is like this. What does a dielectric do? A dielectric basically reduces the field due to polarization, right? So it reduces the field. Now, there is some field here. You introduce a dielectric. What will it do? It will reduce the field. But you have connected a battery. You have given a voltage difference, correct? So if you have given a voltage difference, the field between those two conductors should still remain the same. Because field is nothing but voltage difference by distance. E is dV by dr, delta V by delta R. So if your battery is the same, the field should be the same for the same distance. Now that's the problem. The dielectric tries to reduce the field, but the battery is saying, no, you cannot reduce because I am giving you that voltage, so you need to maintain the field. So there is only one option. You increase the charges to compensate for the loss of the field. So that's why you will end up seeing that more charge is stored on the conductors. And that's how the capacitance or the capacity of storing the charges also increases. Is that clear? Okay, that's how it is. Alrighty. Moving on to the next concepto. Let's try to see this. Okay, this is also done. This is also done. Force, everything. Most of the things are done over here. Okay, now we will also talk about the energy aspects over here. So energy, power, everything. Okay, so first let's talk about energy and power. Energy and power for both batteries, resistors, everything. So if you have a resistor in which current I is flowing and the voltage is V, you will see that there will be some heat loss. So that heat loss per unit time is called as the power loss, and this becomes I squared into R. I squared into R, this is what it is. Also you can write it as V square by R. You can also write it as voltage into the current. All these formulas are one and the same thing. Very important. Now, the next thing that you should know is for a battery. So if you have a battery, and let's say there is some current flowing, the EMF is E, there is some current, and let's say the charge Q flows across the terminals of a battery, then you will see if the battery is supplying current. If the battery is supplying the current, then obviously chemical energy will get converted into the electrical energy. So the battery will do some work. So the work done by the battery will be the voltage difference, which is the EMF, into the charge which flows. Now, if you divide it with time, you will also get the power supplied by the battery. Observe this. So the power supplied by the battery is the work done by the battery per unit time. So when you divide this EQ by time, Q by T is the current, charge per unit time is current, so it will just become E into I. So that's why the power supplied becomes voltage into current. Very similar to this form. Here it's V, here I'm calling it as E because E stands for EMF of the battery. That's all. Okay, very, very crucial. Keep this in mind. Next thing is for basically a capacitor. So for a capacitor, this is positive, this is negative, there is some voltage difference, and there is a charge Q, minus Q over here, okay, and capacitance is C. So the energy stored is basically your electrical electrical potential energy, and that is given by half CV square. We can also write it as half Q square by C. You can also write it as half Q times of V. All the formulas work. There is no difference in that. It's just you are writing it in different terms, just like over here. The next thing, this field which is created between the plates of a capacitor, the field stores that energy, and that energy stored per unit volume is also very important formula. So let's write it down over here. So that is called as the energy density of the field, energy density of the field which is storing that energy. So energy density meaning joules per meter cube. How much joules is stored in 1 meter cube of the volume where the field is existing? That energy density, I hope you remember, it's the formula of half epsilon naught E square. Very crucial formula. Thank you, I don't know. Kinematics next week, Rose. This week, guys, complete before Friday. By Friday, your 12th standard syllabus is done. Imagine, you are moving so fast. We have to move so fast. And next week, 11th standard syllabus done, and maybe not more than 10 days. Okay, before 10th, we'll be winding up. Okay, now moving on to the next one. Whenever you see charging, discharging circuits, and you want to find the relationship of how much energy is stored, how much is the work done by the battery, sometimes energy is lost, always remember this governing equation. It always helps you. You will see that the work done by the battery goes in basically changing the potential energy stored in the capacitor, and the remaining always goes in heat loss. Have you seen that circuit where there is a capacitor and there is a battery? You turn on the switch, the battery charges the capacitor. How much energy is lost from the battery? If battery gives 100 joules or 100% of energy, I think only some percentage gets stored in the capacitor. The remaining gets lost in the form of heat. What is that percentage? Very good, Aditya. I'm very happy for you. And now you have to do very well in your JEE and NEET exam. Jamesburg, please concentrate, don't deviate. Yeah, heat. And how much percentage is lost? It is always 50-50%. If the battery gives 100 joules, 50 joules is lost as heat. Only 50% or 50 joules will be stored in the capacitor. That's how it is. Okay, keep this in mind. Okay, very important governing equation. So that's about your energy considerations. Moving on to the next part. Let's talk about the combination of devices. So first is basically your resistors which are there. So the equivalent resistance is just R1 plus R2 depending on how many our resistors are there. That's how it looks like. And what you will see is through both the resistors, the current is basically same. Yes, it's the same current, but you will see that the voltages will be different. So in fact, if I write the voltage across this resistor, it will be current into resistance of that value. V1 is I into R, V2 will be I into R2. So voltage depends on the resistance. It is in fact, I can say that the voltage across any resistor is directly proportional to the resistance itself, only for series combination, because current is same across all of them. Keep this in mind, very, very crucial. Now, if you move to capacitors in series, okay, let me use the same colors, guys. Capacitors in series. This is C1, this is C2. What you will see is the equivalent capacitor in series is the parallel formula for resistors. So it will be 1 by C1 plus 1 by C2 and so on and so forth. The most common mistake is whenever students solve these problems, they forget to take the reciprocal. This same kind of silly mistake also happens in optics, because 1 by V plus 1 by U is equal to 1 by F. So reciprocals, keep that in mind. Don't make that stupid mistake. In this case, you will see that the charges stored are the same. So basically Q is same across all, but the voltage will be obviously different. In fact, V can be written down as, the voltages can be written down as think about it. V1, Q is CV, so V will be Q by C, so it will be Q by C1. So basically, V is inversely proportional to C. V is inversely proportional to C. Also, if you add the voltages, this V1 and this V2, if you add them like this, you will get the total voltage, the net voltage. Same thing over here. If you add the voltages, you get the total voltage. Is that fine? Very, very important. Okay, let's move on to the next part, and that is basically in parallel. So let's just show few resistors in parallel, R1, R2, R3, so on and so forth. There could be many such resistors. So the resistance in parallel is just as it is, 1 by R1 plus 1 by R2 and so on and so forth will give you 1 by Rp. In this case, you will notice that it is the current which gets divided. Yep, it's the current which gets divided. This is I1, this is I2, this is I. You will see basically I will be equal to I1 plus I2 plus I3 plus so on and so forth. And here the voltage drop will be the same. Yep, the voltage drop is going to be the same. And because the voltage drop is same, I can say, for example, V will be I1 R1 or I2 R2. Hence, I can say from this that the current is inversely proportional to resistance. So the one which has more resistance, less current goes. One which has less resistance, a lot of current will flow through it. The current will try to move through the least resistance path as much as possible. Keep this in mind. Similarly for capacitors, you have multiple capacitors like this. Okay, and let's just join them over here. Okay, so this is C1, this is C2. Fair enough. Over here, the equivalent capacitance in parallel is just the addition. So C1 plus C2 plus so on and so forth. Again, in this case, you will see that whatever charge you supply will get divided among each one of them. So you will see technically Q will be equal to Q1 plus Q2 plus so on and so forth. The voltage difference will be basically same, and because V is same and Q is CV, so charge on 1 will be C1 into V, charge on 2 will be C2 into V. So here charge is proportional to the capacitance. So you can see what is proportional to what in all these examples. Do you need to by heart them? No. How do you do it in the exam? Logic. So think about it and then do it. Okay, very crucial. Wait a minute, I need to wear my glass or else my eyes will start burning. Okay, current, electricity and capacitors are such chapters which are easy to score and understand also. I agree, Rose, because very much related to 10th, and there is a reason why many students do well in 12th. In fact, there are two reasons. Number one, 11th lays your foundation. So if you understood 11th decent enough, 12th becomes easy, lot of related chapters. Number two, you study generally well in your 10th grade because board exams than your 9th grade. So because of which what happens, those things retain in your memory for a longer time, and you will see many of the 10th standard topics are similar to the 12th standard topics: optics, current, electricity, magnetism. So you tend to feel that, oh, this is familiar. That's the reason for that. Okay, moving on to the next concept, and that is your Wheatstones Bridge. Wheatstones Bridge. So in Wheatstones Bridge, what happens is you can have a resistor, you can have a capacitor, it doesn't really matter, something. So this dot over here can be equal to a resistor or a capacitor, really doesn't matter. Okay, it really doesn't matter, whatever you put in between them. Now, if you put anything in between, some device, okay, some D, it could be donkey, it could be dog, it could be resistor, it could be battery, it doesn't matter, whatever you put. If I label them, let's say this is 1, this is 2, this is 3, this is 4. If 1, whatever, capacitance by capacitance, resistance by resistance, I don't know, it could be anything, 1 by 2 is equal to 3 by 4, then it is said to be a balanced Wheatstone bridge. And the moment it gets balanced, this thing becomes completely useless. it becomes completely useless. You can just get rid of it, and then it becomes a very simple circuit. Because if you remove this, 1 and 2 are in series, 3 and 4 parallel, their combination in 3 and 4 in series, 1 and 2 in series, their combination in parallel. As simple as that. Thank you, big dreams. Okay. I am very happy for you, Vishnu. Wow, very good. Okay. Good. So let's move on. Okay. So this is one thing. Now the second thing which I want to tell you is that a Wheatstones bridge can come in different forms. You should know all the forms of Wheatstones bridge. One of the form is this one, which I just showed you. Okay, and you obviously have that device which can be removed. Another form is basically something like this. Observe. By the way, you might have a battery connected over here like this. You can also have that same battery connected over here, and you can just show this maybe like this, and that device you can show it connected from outside. Basically you replace the position of the battery with the device. If you swap it, it doesn't matter, it still is a balanced Wheatstone. You can still get rid of the red thing over there. Now you can still get rid of the red thing over there. You can also rephrase this as this one, this like this, like this, like this, I guess, yeah, and this device right over here. This is also a Wheatstones bridge. R1, R2, R3, R4, this is some device, you can get rid of it. This is also Wheatstone. You can also rephrase it like this, maybe like this, and oh, there is one more thing over here, I guess, yeah, and here, and then this is your terminal, and this is one thing, this is another thing like this, and this thing over here, one second, yep, so that thing over here, this is your device. Okay, this is also a Wheatstones bridge, trust me. So these are your two terminals. If you open this up, this diagram becomes very similar to this diagram. So all these are interrelated. Can you score 450 marks in NEET full syllabus test in Vedantu crash course? Can I get a seat in AIMS? Indu, there are a lot of students who got into AIMS through the Vedantu crash course and through the guidance. So if you feel that you can do it, please go ahead. But main thing is you should have that confidence in you. You should have that hardworking nature. You should have that belief, and you should be ready to work extremely hard, because AIMS is not so easy. But students have done it using the crash course. Let me tell you that. Last year too. Okay, so very, very important. And why this happens is because this point and this point have the same potential. Okay, so that is very important, guys. You should know that. The reason why it becomes useless is because these 2 points are equipotential points. That's the reason for that. Okay, so that's one thing. Now, few more things before we go ahead. Okay, let's see what are those concepts. Sometimes you might have some circuits which are basically, let's say, symmetric circuits, and I want to discuss two kinds of symmetrical circuits. Number one is where, let's say, you have, okay, just one second, you have something over here and maybe something over here, just trying to show some symmetrical circuit. What are these dots? Come on, what are these dots basically? You should understand. What are these dots that I'm showing? What are these dots, guys? These dots are basically nothing but resistors or capacitors, doesn't matter. Now in symmetry, what happens is, this is the point and this is the point across which you want to find the resistance or the capacitance. You find that there is something called as the line of symmetry. Line of symmetry. As in, you know, whatever is there on one side is also there on the other side. I think this diagram is symmetry. Don't go by my actual diagram, but this is symmetry. You can see that this is basically your line of symmetry. Line of symmetry. Do you see that? So whatever is there on the left is there on the right. And whenever that happens, you will notice all the points on the line of symmetry will be equipotential. So these are basically your equipotential points. So whatever is there here, you can just get rid of it. This becomes a useless device. Useless device. You can just remove it. Sometimes this is also called as the connection removal method as well. Keep this in mind. Yes, Zanuba, the 11th standard syllabus may be in the weeks to come. Okay, so let's move on. God is love. Maybe you can put up the question in the chat box. In the comment section. After the session is over, maybe then I can respond to you. Okay, so this becomes useless. This is very important concept of symmetry. Keep this in mind. Another important concept is of infinite resistance. So let's write that down as well. Infinite resistance or infinite ladder kind of questions. So in infinite ladder kind of questions, what you have is, let's say, one device and then second device. It could be capacitor also, doesn't really matter. Then again one, and then you have two, and then again one, and then again two, and let's say this just continues till infinity. This just continues, and you have been asked to find out the equivalent resistance or capacitance between these 2 points. So the first thing you need to do in these kind of cases is assume that the equivalent capacitance or resistance between them is just X. Just assume. Now, if I shift the 2 points over here, it really doesn't matter if I ignore the first 2 resistance or capacitors. You will notice that this whole bunch, which is again starting between this point and this point, it's as if the same diagram as original. This whole thing also has an equivalent capacitance or resistance as X only. So in fact, you can redraw the diagram like this, as this 1, this 2, this goes over here, and this whole thing you can just fill it up with one single capacitor or one single resistor. That's it. And the equivalent between them is also X. So solve this circuit, 2 things in parallel, their combination in series with this one, their total combination is again X. You will always see that in these kind of questions, you will always get a quadratic equation. You'll get a quadratic equation, and quadratic equation always has how many roots? 2 roots. You will get 2 roots. The negative one, obviously you're going to ignore it. Or the resistance or capacitance can't be negative. So the positive one is the right answer. That's the flow of the question. Okay, is that fine, guys? Is that clear? Okay, we are going to do some circuits as well. Now, whenever you get these symmetric kind of circuits, sometimes you might have an useless device. Sometimes in symmetrical questions, you might not have an useless device. So in those cases, you might get a joint. For example, what if you get something like this, a node? If you get a node on the line of symmetry, if you get a node on the line of symmetry, then what you need to do is always split the node. So this is your line of symmetry, guys. The same thing. This is your line of symmetry. Then always split it, open it up along the line of symmetry, meaning do it like this. Open it up. I'm just showing you what is the transformation needed. Just open it up like this, and make it bigger. So along the line of symmetry. Now, once you make it into an elongated point, so you have basically stretched the node. So you have to stretch the node, okay, elongated. Now you see this part is basically your useless part. The moment you stretch it, that is your useless part. So in the next part, you will notice that you will get this as just one V and one line over here. That's it. You have removed the connection. So that's why this is called as the connection removal method. So whenever you see a node on the line of symmetry, always think of connection removal. So that node needs to be stretched along the line of symmetry and then remove that connection completely. When you don't have a junction but you actually have a device, then you can as it is remove it. There is no need of stretching. Is that clear? Everyone understanding it? Okay. Last few things, and that is basically your measuring instruments. That's your potentiometer and your meter bridge. So let's talk about meter bridge first. Meter bridge over here. So if you have an unknown resistance, and this is a standard resistance, and you connect it across a potentiometer wire, this is your potentiometer wire, highly resistive wire, and you power this up using some battery. Okay, power it up using some battery. What you do is basically take this point using a galvanometer, touch it at different points. So let's say this is A, this is B. There is one point where there is no current which will flow, and when the current is zero, that is called as null deflection. That is called as null deflection, and this is basically a Wheatstones bridge at the end of the day. This is nothing but a Wheatstone arrangement. Wheatstone arrangement. Think about it. Why? R1, R2, R3, R4, and there is something in between. When no current flows, that means these 2 points are at the same potential. That means it's a balanced Wheatstone. It is a balanced Wheatstone, and whenever it is balanced, you will see that you can just use the condition for null deflection, which is X by R, unknown by known, is these lengths could be L1, this could be L2, is nothing but L1 divided by L2. That's the standard formula which you're going to use. Exactly. Very good, Avantiki, Nitish, Samyukta, Vartika, excellente, Anisha, Shruti, very good, God. Next device which you should know, and that is basically your potentiometer. Now, in case of a potentiometer, there are two parts, primary circuit and the secondary circuit. Let's start with the primary circuit first. So primary circuit will have, let's say, a battery, some kind of resistance. This is again your potentiometer wire. Okay, it looks little similar, but obviously there are a lot of different things. The job of a meter bridge is to always measure the resistance. The job of a potentiometer is to basically measure voltage difference, compare EMF, or even to measure the internal resistance of a battery. So all are the different purposes of a potentiometer. Okay, so there is a battery, there is a resistance, this is a potentiometer wire, this is AB. Now whenever you see such an arrangement, first of all realize there will be some current flowing in this. So let's try to mark all those parameters. So there is some current which will flow through this. Okay, some current which will flow, I'll just call it as I. That current can be found by normal things, like current is the total voltage, you know, and by total resistance. That's a standard thing. Now what you need to always find is something called as the potential gradient. For that, I'll first make you understand what is the voltage between A and B. The voltage between A and B is the current flowing through it into the resistance of A and B. Now, if you divide this by the length of AB, so divided by the length of AB, this is called as the potential gradient. Potential gradient, volts per meter, volts per centimeter, whatever you want to call it. It's how much voltage drop am I getting on that wire, 10 to 8, 8 to 6, 6 to 5. How is the voltage dropping per meter, per unit length? That is volts per meter, that is your voltage gradient. VAB is the total voltage difference, LAB is the length of that wire. Is that clear? Okay. Yeah, the stream started at 7 o'clock. Every day 7 o'clock you're going to see me over here. Very crucial. Alright, now keep this in mind. I'm just going to leave it as it is over here. The next part is the secondary circuit. This was all a part of your primary circuit, the main circuit, primary or driving circuit. Now the next thing which comes is your driven circuit. So let me show that over here. I don't know, it could be anything. It could be a battery, it could be some resistor, I don't know, some device. Always take one terminal, connect it over here, and the second terminal via a galvanometer, connect it over here till you get zero current. This is obviously your null deflection. This is your null deflection point. Let's say this is point P, this is Q. When null deflection happens, you will see whatever voltage is there across here will be the same voltage across these 2 points. This is point J, that's your jockey. Whatever voltage is there here will be also the voltage here. So you will notice that voltage across PQ will be equal to voltage across AJ. And voltage across AJ is a very simple thing to do. How to do that? Observe. The voltage across AJ is going to be, observe, if I know the gradient, this much volts falls per this much meter, and I know that this distance is delta X. Think now, I know the voltage falls at so much rate per unit meter. For this much meters, how much will the voltage drop by? You just have to multiply the potential gradient with that. So that's going to give the answer. Let me just write it properly over here. So guys, what will happen from this is that you will get the voltage difference across PQ is that potential gradient, is the potential gradient multiplied by delta X. So that's your formula which gives you the voltage, EMF and other things. Very important. The purpose of a jockey in a potentiometer is like a sliding contact. So you do not know where the current is zero. So you're going to move that J point everywhere till you get zero deflection or null deflection. So that's basically a sliding contact. That's all. Okay. So only the manganese wire is kept in the potential. You can use different kinds of material also, but there could be some standard materials which has good amount of resistance. Okay, so that's the logic behind the potentiometer. Okay, I think we have done most of the stuff, guys. Okay, if there are some more pointers here and there, then please go through H.C. Verma, the only book for theory, for formulas, for concepts. That's it. Okay, no other book. Please don't read only from NCERT. NCERT, yes, as a reference, good, but for studies, revision, concepts, clarity, it is only H.C. Verma, be it JEE, be it NEET. Any teacher might tell you anything, trust me on that, H.C. Verma never fails. Let's move on to some questions which are going to come up on your screen now. There we go. 5 cells each of EMF E and internal resistance R are connected in series. Due to some problem, one cell is wrongly connected. So what is the equivalent EMF and equivalent resistance? Come on, figure this out. Yeah, NCERT is always difficult to understand. High five. Cengage, no, not a good book for students. Good book for teachers, good book for content makers, good book for giving tests, but for students, definitely not great. Mokshagana. Okay, let's try to do this. First of all, 5 cells, one of them is wrongly connected. 1, 2, 3, 4. 5th one is like this. The moment this happens, the net EMF will be E plus E plus E plus E, but minus E, because this is opposite. So it will be just 3 times of E. That's it, 3. So obviously option A gets eliminated, option D gets eliminated. The last thing is the internal resistance. Now remember, the resistance remains the same whether the current goes like this or like this, it's R only. So whether this battery is connected this way or that way, doesn't really matter. So the R effective will be just 5 times of R. So 5 times of R is right over here. A lot of people will think this. No, this is the wrong answer. Keep this in mind. Aryanth is good for questions, not for theory. For theory, H.C. Verma. H.C. Verma questions are also good, but yes, questions get limited after a point of time. You need to explore more. So that's when you use Aryanth books or Tattva material or your coaching material and other things. Perfecto. Okay, that reminds me also of one more formula which I think I can give you guys over here, and that is batteries in series and batteries in parallel. Let me just touch upon that. So whenever you have batteries in series, this is E1, this is R1, this is E2, this is R2, the effective EMF of series is E1 plus E2 plus so on and so forth, but I will put plus minus because some of the batteries can be opposite in connection, like they can be opposing the flow. So that's why the effective EMF is this, plus or minus. Minus depends on whether it is helping or opposing. So I'll just put it over here. So plus is when it helps and minus is when it opposes. But if you talk about the resistance, well, the resistance in series equivalent internal is just R1 plus R2 plus so on and so forth. There is no plus or minus, resistance has no sign. Similarly, if you talk about parallel combination, as in like this, batteries are connected this way, okay, and you want to replace them with one single battery. This is E1, this is E2, R2, R1. The effective EMF is given by this formula. Effective EMF in parallel is given by E1 by R1 plus E2 by R2 plus dot dot dot, the whole thing divided by 1 by R1 plus 1 by R2 dot dot dot. This is your effective EMF in parallel, and the equivalent internal resistance in parallel is just given by 1 by Rp is 1 by R1 plus 1 by R2 and so on and so forth. This is your standard formula. That's it. But this one, E1 by R1 plus E2 by R2 upon 1 by R1 plus 1 by R2 plus 1 by R3, so on and so forth. Very, very important. Okay. That reminds me also about Kirchhoff's law. Oh, let me just touch upon it. Thank you guys for reminding me of that. So Kirchhoff's current law, first of all. So if you have a node and there are multiple things which are coming inside, multiple currents which are coming inside, multiple currents which are maybe going outside, the net current which is going in is the net current which is going out, and this is based on the law of conservation of what? This is based on the law of conservation of what? Come on, put it up. And we'll go to KVL also. It's based on the law of conservation of? Rose, you can find a video of mine where I have explained it in detail. If you want, I will just share you the link after the session ends. You can just leave a comment. Sir, please share this as you told. I'll definitely do that. Yes, it's the law of conservation of charge. Perfect. I just wanted to do a health check whether you guys are alive or you guys have turned into zombies. Thankfully, many of you are alive and not turned into zombies yet. Okay, and this is based on basically nothing but that the net potential difference is zero. It's basically law of conservation of energy. So it just says that if you start from a point and you go across the circuit and come back to the same point, then the total sum of all the voltage differences in a loop is going to be zero. Every device will have some drop. Sometimes it can increase, sometimes it can decrease, and when you come back to the same point, the total voltage drop is zero. And there are some very important sign conventions which I'm pretty sure you should know. Let's talk about them also. Let's talk about battery. So you have a battery, and then you have let's say a capacitor. Okay, this is your plus Q, this is minus Q, and last thing is your resistor. Resistance is the most notorious one. Okay, other things are a little bit simple. This is current, this is capacitance. Okay, so first, if you take a battery, this is negative, this is positive terminal. If you go from minus to plus, low to high, when you go from low to high, you're increasing, you're jumping. So when you go from here to here, it is plus E. Low to high, always increasing is plus. Here, this is minus, this is plus. If you want, I can label it properly over here like this, maybe. Minus, this is plus, so that it is easy to read it over here. So this is minus, low potential, high potential, it's jumping if you go from here to here. So it will be plus, V is Q by C, so it will be magnitude wise Q by C. If you go exactly the opposite way, like from here to here, it will be minus E. If you jump from here to here, it will be minus of Q by C. That's how it works. Okay. Now, in case of resistance, current flows always from high to low potential. High to low. Current, where does it flow? High to low. So this is high, this is low. High to low, that means a drop. So when you go from here to here, it is minus IR. It is minus IR. Keep this in mind. And the exact opposite way, high to low, low to high. Low to high means increase. So it will be basically plus IR. This is the sign convention which you're going to follow. Yes, PL, that's what you need, bacha, definitely. Got it? So keep this in mind. Okay, let's move on. Next question. There is a air-filled 1 picofarad capacitor plate. When the plate separation is doubled and the space is filled with wax, the new capacitance is 2. What is the dielectric constant of the wax? Let's try and do this question. So earlier we had a 1 picofarad capacitance, and this 1 picofarad will be epsilon naught A by D, of course. That's a parallel plate capacitor. In the second case, this distance was D. In the second case, what have you done? The distance is increased. So the separation is made as 2D, and you have filled some material whose unknown dielectric constant is K. What is that constant? The new capacitance is 2 picofarad, and 2 picofarad will be epsilon naught K. K will come there. Area by D, but 2 times. Now out of these numbers, I can separate out few numbers like epsilon naught A by D, K by 2, I'll keep it as it is. From here, I know this thing is exactly this thing. So that should be nothing but your 1 picofarad. So I'll just put 1 picofarad over here, and rest of the things as it is. It is just K by 2. This is 2 picofarad. Pico goes. So K will be nothing but 2 into 2, which is just 4. That's it. Option B. Perfect. Very good. Excellent. I can see many of you have also answered, but some of you got it wrong. But I hope you now understood where you made the mistake. Either you forgot K or you forgot the distance. One of them. Or you made some calculation blunder. So realize these mistakes and work upon them. Moving on to the next one. Happens. No problem, Darshani. It's okay. You are allowed to make mistakes. Now, a spherical drop of capacitance is broken into small drops of equal radius. The radius of each small drop is how much? Radius. Guys, this is not radius. This was supposed to be capacitance. You can see the options. This is the capacitance. So try to understand what has happened. There was a big sphere or radius R. It had a capacitance of 1 microfarad. Capacitance, a big sphere. Well, I know this. This is isolated capacitor. Isolated capacitor is having a capacitance of 4 pi epsilon naught R. Now you make small parts of it, small drops, 8 of them, 8 drops, and each one of them has a new radius. But what is the new capacitance? For that, I need to know what is the new radius. How do I find the new radius? Well. You take the drop and break it. So obviously the volume should be conserved. That's all that you need to do. So conserve the volume. So basically conserve total volume. So in every question there is always some law or some principle, some conservation. So you need to identify what remains same, what increases, which principle, which law should be used. So here you're breaking it up. So that breaking up part is the keyword for this law of conservation of volume. So 4 by 3 pi capital R cube initial volume is 8 times the smaller volume, which is 4 by 3 pi small r cube. 4 by 3 pi goes. So r cube is equal to 8 r cube. So taking cube roots, r will be equal to 2 times of r. So naturally this r over here should be replaced by 4 pi epsilon naught r divided by 2. But wait a minute, 4 pi epsilon naught r is just 1 microfarad. So this is 1 microfarad divided by 2. That's the answer. That's the new capacitance. Yep, it is option A. Done. Got it? So the radius has become half. Synapse maybe more half an hour, 45 minutes. Moving on to the next one. Yep. 2 microfarad capacitor is charged to a voltage of 200 volts. Now it is isolated, separated. It is now connected with another capacitor which is not charged. What is the new potential becomes 20. What is the second capacitor? Let's draw the scenario one by one. 2 microfarad connected to 200 volts. So I'll just draw a 2 microfarad which is connected to basically 200 volts. Obviously there will be some charge which will be stored on it, So that charge, I can just figure it out. I don't know, I might need it. CV, right? So C is 2 micro into 200, which is nothing but 400 micro coulomb. That's it. That's the charge which is stored. Okay. Now what has happened is you are disconnecting it. So you are disconnected it. That means the charge will remain as it is. So plus 400 microcoulomb and minus 400 microcoulomb. It's separated. And now you connect this. You connect this to another capacitor. Which value I do not know. There is no charge stored on it. I'm going to connect it. So let's see what happens when you connect. So this capacitor and this capacitor I have connected. This is C. This one is 2 microfarad. Now it is given that the common potential becomes how much? 20 volts. I know what this is. Think about this combination. If I look at this way, what are these two in? Come on, put it up in the chat box. Mokshigana, there is a material called as the JEE Crash Course Assignments with notes, lecture PDFs and mock tests. That's the thing which you should do in the last few months just before JEE Mains. It's the proven material for rankers, proven material to improve your scores. What are these two in? Obviously, yeah, they are terminals, but what are the two capacitors going to be in? The two capacitors are going to be in parallel, and we know capacitors in parallel, voltage here is same, charge not same. Charge is not same. Acha, fair enough. Now what's the next thing? Think about it. The charge of 400 will get divided into two parts. So maybe here it will have Q1, here it will have Q2. These two are in parallel. They are in parallel, and in parallel voltage is basically same, right? If voltage is Q by C, hence I can write Q1 by C1, which is 2 microfarad, will be equal to Q2, which I do not know, divided by, what is it? C, which is microfarad again. So rearranging it, what shall I get? I'll get, oh, wait a minute. Do I even need to do this? Let's think about it. I don't even need to do all this. I don't need to do all this nonsense. That's simple. I'll tell you what we can do. These two capacitors are in parallel. They are in parallel. Charges are different. What is their equivalent capacitance? The equivalent capacitance is 2 plus C, correct? This is your equivalent capacitance. And this equivalent capacitance stores how much charge? This charge stores how much? 400 microcoulomb. For how much voltage? 20 volts. Just make an equation for that. So 2 plus C into, Q is equal to CV. That's all I'm going to do. Q is equal to CV. Q is 400. So 400 micro is equal to C, which is 2 plus C, into the voltage, which is nothing but 20. So this is again in micro, guys. All this is micro cancels. So 400 divided by 20 is equal to 2 plus C. This 0 goes. This becomes 20. So capacitance becomes 18. And I have 18. There you go. Option C it is. So I don't have to do unnecessary nonsense. I know they are in parallel. Equivalent will be 2 plus C. Their equivalent combination will store this, because this plus this is basically this. That's what the equivalent combination will store. Keep this in mind. Okay, so that's how I have simplified the problem. Done. Understood, guys? Clear? Moving on to the next question. No problem, Sunapsi made some mistakes. Sir, can I join the crash course now? Yes, Deepak, you can definitely join it. The link is still open. There is a link in the description box. You can definitely join, bacha. Don't worry. Okay, let's move on. Now, in the next question, a parallel plate capacitor with some slab is filling the space between the plates, which is charged to V volts and then isolated. Now, a slab is taken out and another slab is put between the plates. What is the ratio of energy stored later to that initially. So it's a ratio. So two situations, I will take two situations, draw, solve, and finally divide. Let's start one by one. The first time, capacitor C, you are filling it with a slab of dielectric constant 3 and charge to V volts. So this is V, this is 0, let's say, and there is some energy stored in it. So the initial energy U1 will be half. By the way, the capacitance C over here is when there is air in between. So when there is a slab, it will be basically 3 times of C because of the dielectric slab into the voltage square. So it will be basically 3 CV square by 2. That's your initial energy stored. Got it? Hard copy of Tattva is only available when you are in the pro course long-term batch. Otherwise, it is not available. Else soft copy. And in the crash course, we give you the soft copy because you have to do it very quickly. So it is provided in the form of assignments. You will not get it in the form of Tattva. Only the material which you can do in the last few months. That's all. Now, the next thing is when you put another slab. So let's take the same capacitor, but this time the dielectric constant is how much? 2. But remember, you have isolated it. This word is important. The word isolated means what? This word isolated, what does it mean? You have separated it. That means Q is same. The charge does not change. You disconnect the battery, so the charge has nowhere to go. The charge remains the same. And that value of the charge is C into V. C is 3C and voltage is V. So that is the value of the charge which remains as it is. So this capacitor does not have V voltage difference. That's the catch. Many students are going to fail here. Yeah, many students are going to fail over here, definitely. So here it will be plus Q, here it will be minus Q, only because it is isolated, charge cannot change. Now, when you try to find the final energy, U2, I will use half Q square by C, half Q square by the new C, C is 2C, and charge is 3CV, I guess, so squaring it, so it will be 9 C square V square by 4C. So this will be 9 CV square by 4. Now you just have to divide them, that's all. So just divide them, U1 by U2, that's all. So U1 divided by U2 will be that one, which is 3 CV square divided by 2 divided by this one, 9 CV square divided by 4, 3 and 9, everything goes. This will be 1 by 2, 2 goes on the top, 2 by 3. Just check this out. 2 by 3 is there, option A. Oh, 3 by 2 is it? They have asked in the capacitor later to that initially. Acha, later to initial. Okay, so basically this will be U1 by U2. So U2 by U1 will be 3 by 2. Yeah, so that's the answer. Option B, of course. Yeah, so later to initial. Yes, HiPi, you can use Cengage, but I generally don't prefer Cengage for solving problems. I would say go with DC Pandey and go with 40 years, previous years question bank, or 45 years, 42 years, whatever, by Arihant. That's what you should give. Okay, cool. Let's move on to the next question. Figure this out. Yeah, thank you, Shruti, for reminding me to have water. Let me also have some water. Will there be more competition second attempt? In fact, Akshay, I feel there will be a lot of competition even in the first attempt because many students have prepared very well. Can you tell me the name of last 30 days preparation? I mean of the book. Mokshgana, you should solve previous year papers. The crash course material link is there in the description box below. That material, okay? That's not a book, that's a material which is given to you. Yes, you can refer to DC Pandey for JEE, of course. Hello Anushka Bele, why does your name ring a bell? NEET 2025, obviously. The competition will always increase every year. It will always increase every year. This year, by the way, there is one third front, and that is your CUET exam. And because of that, you will see the competition is going to be even tougher. It's like a mock test before your NEET and JEE. So CUET is going to be written by almost 10 lakh plus aspirants. It's before your second attempt and NEET attempt. So a lot of people are going to write it. Sayonara na namikaze-kun. I think Synapse is Kirito, if I'm not wrong. Our famous notorious student, Charan Sai Gumula. Yeah, true. Okay, shall we solve this question, guys? Shruti is back from water break. So in 2023, what will be the cutoff under 100? Oh, under 100? That's very close to the full marks. Just remove some 20-40 marks from the full marks. That's where it will be. No, my legs don't pain because I am not in offline teaching, right? Online. So I take YouTube classes, but my other classes where I am taking on my platform, the Wave platform, the crash course 12 standard batch, there I'm sitting aram se. My chair is right over here. So I sit and teach. So it's actually good to stand. Okay, fine. No problem. I'll ignore your surname. JEE कैसे है आप? Sir. Oh, Sir G कैसे है आप? Oh my God. I was like, Aryan, why is he asking, Sir JEE कैसे है आप? I'm thinking. मैं बहुत ही बढ़िया हूँ Aryan. Is errorless good? Yeah, okay. Okay, मेरा क्वेश्चन, आयुषी तुम्हारा क्वेश्चन क्या था? Is what is this? USS is good or not? I don't know what is US. Hi Sapna. I'm not sure. God is love. I mean, 600 plus bacha. 600 plus. University, something like that. Errorless. Oh, no, Ayushi. I won't suggest that so much. I won't suggest that. Hello, Sri Study. Okay, guys, I know you guys want to interact with me. I want to honestly have a very good session with you where I chit chat with you. I don't know when, but time is so limited. I'm on English channel, I'm on Hindi channel. I have to do so many things. JEE, NEET, and all the exams around the corner. 10 students are passing out. 11 students want something. Trust me, I want to do so many things, but just give me some time. That's all. Okay, let's concentrate right now on this problem. And you know that we are right now in the most critical juncture, just few weeks before the exam. You need that motivation, but I'm coming with something this Saturday. Stay tuned on the channel for everyone. Okay. Yes, I have back. Okay. Let's talk about this question. Now, many students will be like, Sir, I remember you told about something about the node. If you have a node, you can pluck it out, remove it. Well, I told you about the node, but I told you only about that in a peculiar situation, and that is symmetry. I don't think by any means this is symmetric. I mean, like 8, 4, 2, 6, no ways, this 3, 6, no kind of symmetry out here. So you would be wrong, you would be misguided if you think that you can expand that node and remove it. That's wrong. But there is something else which you can do. That is looking at which point is at which potential. If you take at this point is at A potential, A is some volts. The same wire will have same voltage. This is all a wire. This is also red. This is also red. I'm using same colors which have same potentials. That's all. Now for the side B, this point and this wire, obviously same potential. Even this one, same potential. Even this one, same potential. The one in the middle is something else only because it's not connected directly to anything else. I have a feeling this circuit is actually simple, and I'll tell you how. If you observe carefully, guys, 8 and 2, red and yellow, it is basically across the same voltage difference. It's across the same voltage difference. Hence, when the voltage difference is same, what is it? It's obviously parallel. So you might as well take this point and take it here. These 2 points you can combine it together. Not just that, even for 6 and 4, these 2 blue points you can combine it. You can see 4 and 6 are also in parallel. So might as well redraw the circuit like this. So I'm just going to show something like this. The outermost resistors first. This is A, this is B, that is 3 ohm, this is 6 ohm. These two together, so probably like this. Yeah, and these two together like this, maybe it's one and the same thing, right? And connect it like that. Okay, so this is 8, this is 2, this is 4, this is 6. Now 8 and 2 are in parallel, obviously. You can see that right now over here. So their equivalent will be R1 R2 upon R1 plus R2. 8 to the 16, 8 plus 2 10. So that will be nothing but 8 by 5 ohms. Same thing over here, 4 and 6 are in parallel. So it will be 4 into 6 by 4 plus 6. 24 by 10, which is 12 by 5 ohms. These two together are in series, so keep that in mind. So I can redraw the circuit further. So the outermost resistors first. This is your B, this is A. That is 3 ohms and that one is 6 ohms. And this one over here, I can just write it as the combination of this with that, because this and this are one after the other, so they are in series. So it will be 8 by 5 plus 12 by 5, which is 20 by 5, which is 4 ohms. Now all the three are in parallel, so just equivalent RAB will be 1 by 3 plus 1 by 4 plus 1 by 6. So their LCM is 24. This will be 8, this will be 6, this will be 4. It's 6 plus 4, 10, 18. So this will be 18 by 24. I can divide it by 6. This will be 3, this will be 8. Oops, sorry. What am I doing? This will be 3, this will be 4. So therefore, RAB will be nothing but 4 divided by 3 ohms. That's the answer. This is not menti bacha. Oh yes, it is 4 by 3 ohms. That's it. Charan Sai, I would prefer DC Pandey with previous year questions. Option B it is. Very good Anisha, very good Sekhar, Riya. Excellent. Easy Vishal, finally. So to realize that is very tricky. Many students can be misguided, can do some wrong things, and in the exam it should click. Oh, this is a disguised form. Let's move on. What do we have here? In the following figure, current through the 4 ohm resistor is how much? How much is the current through the 4 ohm resistor? 4 ohm is here. Symmetry, nah. Wheatstone, yes, maybe. 24, 50, 10. Yes, it's a balanced Wheatstone. You can see it is definitely balanced because 20 by 4 is 50 by 10. So this is utterly useless. Just ignore this even exists. Just throw it out of your mind. Now the one on the top and one below. Question is, what's the current in the 4 ohm resistor? Okay, fair enough. So the current will get divided obviously like this and like this. This is I1, this is I2. Naturally 1.4 is I1 plus I2. It gets divided. Same current will also go over here. I1, same current will go here. Okay, 20 and 4, they are in series. 20 and 4, they are in series. So 20 and 4, that will make it 24 ohms. And this 50 and 10 will make it nothing but 60 ohms. The reason why I did it is because when the two resistors are in parallel, this and this parallel, voltages are same. So 24 ohms is parallel with 60 ohms. Voltage is same. V is IR. Hence, current is inversely proportional. So I1 by I2 is R2 by R1. Inversely proportional. Voltage is IR. So current into resistance product is same. Inversely proportional. I1 R1 will be I2 R2. Is that clear? Very good. Yes, Sapna, you can ask your question. Now it's very simple. Just probably you will have to do some componendo dividendo. I will probably put 2 here and then 1 here. You will understand why. This is 2, this is 1, this is 1, this is 2. Fair enough. Just use componendo. So I2 plus I1 by I1 will be R1 plus R2 divided by R2. I1 plus I2 is 1.4. So 1.4 divided by I1 is equal to R1 plus R2. That's going to be 60 plus 24. 60 plus 24 divided by R2. R2 is going to be 60. So just have to rearrange this equation and just see what you get. So I1 will be 1.4 into 60. So I can write it as 14 into 6 divided by 60 plus 24. That's 84. Oh, that's just going to be 1. So 1 ampere. That's it. Clear? Very good. DC is very harmful or AC? Oh, it depends. It depends. Okay. So, on the voltage and all of that. Okay. So, the answer is 1 ampere. So, basically what happens, who is it? Sapna Sharma. So, what happens is you should always check the RMS voltage of AC, because RMS is the DC equivalent. So, 220 volts AC, maximum voltage if it is 220 volts, does not mean the average perceived value is 220. It will be lesser, which is V peak by root 2. So the voltage which you see in the devices, supply, etc., that is usually the RMS. The max value is even higher than that. So you should always compare the RMS of AC with the DC value. That's how it goes. Silver. What? Yeah. Oh my gosh. Let's not get there. Okay. So, yes. Hello, Ulas. In the part of a circuit shown in the figure, the potential difference is how much? Wow. Beautiful question on KVL. Let's try to do this question. So, basically, can I use the highlighter? I've never tried the highlighter. How does it work? I don't know. Potential difference between G and H. Okay, let's try the highlighter. Wow, this is how it works. I like this. I like to move it. I like to move it. So this is the path and I like it. Okay, cool. So I'm interested in the potential difference between these 2 points, and the best way to do that is a modified Kirchhoff's voltage law. That's it. So how does it work? VG minus VH is basically similar to Kirchhoff's voltage law. In KVL, you start from a point, go along the circuit and come back, and you measure the voltage differences. The total sum comes out to be 0. But if you start at a point and end at a point, then when you travel and when you add the voltages based on whatever the sign convention, the net voltage drop may not be 0. That's all. Yeah. Okay. Now let's try to do this. First of all, you have to just add the voltage drop across all the devices that you're going to get. Let's try to figure it out. So I need the voltage drop across this, this and this. I think this current is mentioned 2 amperes. So obviously the same current, this same current which is flowing here will also, wow, you can see some mixing of colors, blue and yellow becoming green. So this is also 2 amperes. Okay, fair enough. Oh, I need also the current here. Will the same current go here? I really doubt about it. Okay, so look around. Oh, I can see some currents given over there. This is 1, this is 3. Maybe using this, maybe I can find it out. How? Kirchhoff's current law. Okay, if this is 1, this is 3, how much will this be? Come on, put it up in the chat box. If this is 3, look at the arrow marks quickly and answer the question. Tanuj, how can I teach this in minutes? I don't know. I like the subject. I like teaching. I want you to improve. So if I am ready to do so much of hard work, obviously Tanuj, Chandra, you should be able to do much more hard work than me. You are much younger than me. I'm at least twice your age, I guess. Okay, so this will be 4 amperes. Okay, if this is 4 amperes, this is 2. I think I know what's the current here. This is going to be 2, because 2 and 2 mixes and gives you 4. So 2 and 2 gives you 4 over there. All I have done is used Kirchhoff's current law. That's all to find out the current. I need this to find the voltage drop. Let's get back to this question now. The first device is the resistor. Current is like this. I'm also going this way. In the direction of the current, the voltage drops for a resistor. So just put a minus sign. Drop will be IR. I is 2, resistance is 4. So 2 into 4, that's the first term. Next term is the battery. This is low, this is high. I'm going like this. Low to high, it's a jump, it's an increase, so plus. Battery's voltage is 3, so just put 3 over here. That's it. Next, resistor. High to low, I'm going in the direction of current. High to low, that's a drop, so it's going to be negative. Current I 2 and 2, so resistance is also 2, so 2 into 2, that's it. Then over here, current is going like this, but I'm going this way, opposite, so low to high. So low to high means it's a jump, so plus, and the value will be IR 2 into 1, so 2 into 1, that's it. So just solve this and just see what is the magnitude of this VG minus VH. I'm only interested in the magnitude, guys. Come on, point it out. I don't know, saying 7 volts, is it? Is it 7? All right, 7 volts, yes it is. Very good, guys, perfect. So 7 volts is the answer. You can do it, minus 8, plus 3, minus 4, plus this, whatever. Okay, the potential difference will be this much. Perfect. Understood, oh, clear, oh, amazing, oh. Can we go ahead, oh, to the next question, oh? There it comes. Wow, a potentiometer, guys. Potentiometer. Very good, Shaker. Guys, important questions coming up now. So focus, full Josh, full energy, full concentration. So we have an experiment to measure internal resistance by a potentiometer. The balance point is at 2 meters. When shunted, shunt means parallel, if you get confused, it's basically parallel. And 3 meters when shunted by 10 ohm resistance. So let's draw the potentiometer circuit first, just to get a feel of it. This is how it looks like usually. Then you have the potentiometer wire. This is point A, this is point B. And this is your potentiometer wire. This is your potentiometer wire. Okay, fair enough. And you connect some battery. It is found that a balance point is this much when a cell is shunted by this much. Okay, so I need to connect a battery. So let's just try this out. So we have a battery over here. We have a battery over here, some internal resistance, and it is shunted, meaning in parallel you connect another resistor. So this is EMF, this is small resistance. Now you connect this circuit with this circuit. That means you will join this point over here and you will join this point via a galvanometer so that you reach the correct null deflection point. This is, let's say, your X. This is, let's say, your X. Fair enough. And everything else is fine. Okay, cool. Now, what do we need to do? Let me mark some more points, P and Q. We know when null deflection occurs, current is 0, and whatever voltage drop is there here is also the voltage drop here. Obviously, the voltage drop across points A and J is also the voltage drop across the points P and Q, which is also the voltage drop between these 2 points. P is same as this, Q is same as this, so the drop here is also the same as the voltage drop across R. Fair enough? Cool. The voltage drop across R can be found out by a simple logic. The current can only circulate in this circuit, but it won't go here, it won't go here, because null deflection, no current can flow. So this circuit and this circuit are 2 completely different circuits connected by wires, but still no current flows because voltages are same. So these are 2 different circuits and current is independently flowing in both the circuits. That's what a potentiometer at the end of the day is. 2 different circuits connected, but still no current flows between them. Independently, yes. Between them, no. Now this current is useful for finding the resistance's voltage difference, because VR will be I into R, and this current will be obviously E divided by R plus R, and this R will come over here. And this voltage difference across A and J, oh, I know what this is. If I know the gradient, I can replace gradient by, instead of writing all these words, by this symbol, let's say, opposite, upside down delta, that's gradient. It's the voltage gradient into X, because what is voltage gradient? Voltage gradient gives me how many volts are there per unit meter? For 1 meter, this much volts drop. For this many meters, how much voltage will drop? That's what gradient is all about. So this will be nothing but your gradient into x. See if you guys agree to this concept. Varalu gamer quite late, but no problems, just watch it. Very good. Is that fine? So it's the gradient, it's the volts per meter into the meters, gives me how much voltage is dropped across these 2 points. Very simple unitary method, nothing great. I did this analysis because I'm going to do something for both the situations mentioned in the question. Observe. First, situation 1. First time, this is your x1. This is your balancing length. When the shunt resistance, that means this is 5 ohms. And in the second situation, observe, when the length is this much, 3 meters, it is shunted by 10 ohms, that means this is R2. Now if you notice over here, delta inverse, which is your gradient, E and small r are the same. So if you divide them, just think what will happen. Just think about it. For example, if I write it like this, delta x1 is equal to E1 R1 divided by R1 plus R. This whole thing divided by this thing E is the same, my bad. EMF battery is the same. So it will be E R2 divided by R2 plus R. The best thing is delta gets cancelled. Check this out. Delta gets cancelled, E gets cancelled. So x1 by x2 will be R1 by R2, and this thing goes on the top, this thing comes below. R2 plus R divided by R1 plus R. Wow, so cool. Now I just don't know R. So let's find it out. X1, X2, R1, R2 I know. Start substituting. X1 is 2, X2 is 3. This will be R1 by R2. R1 is 5, R2 is 10. So 5 by 10, and this is 10 plus small r, and this is 5 plus small r. So let's solve this now. It's very simple. 5 and 10 goes 2 times. 2 2s are 4. This thing comes on the top. So 5 plus small r. This is 10 plus r, and there is 3 over there. So 3 into 10 plus r, of course. So this will be 20 plus 4r is equal to 30 plus 3r. So take it over here. So it will be basically R. 30 minus 20 is 10. So 10 ohms should be the answer. Yes, very good, Darshini. There you go. Yeah. So if you know the knowledge, if you have the knowledge of potentiometers and if you know how it works, yeah, there are 2 distinct circuits. No problem is very difficult. It's just solving it in steps. The first step was to understand how is the balancing length related to the internal resistance. So first I got rid of that problem. Then I know there are 2 situations given. So maybe usually it is either addition, subtraction, ratio, multiplication, one of these things. So I wrote it down, the same equation 2 times. I divide, so many things got cancelled, rest is just substitution, that's all. Yes, I don't know. Is this type of question, will they give the diagram? No, they will not give the diagram. This I have drawn it. So that's why you should know the diagrams in and out. They might just give you the diagram if it is needed, if they feel like, but there is no compulsion. Moving on. Why are physics and maths so great? I don't know. For some people, arts is great. No subject is great, guys. Every subject has its own importance. I used to think science is the biggest thing, but now I feel I should have learned history. Maybe I should have learned English. Maybe I should have learned literature. Maybe I should have also learned many other things, finance. So all subjects have very important role to play in our lives. So there is nothing which is bigger, nothing which is smaller. Keep this in mind. Cengage is very random. It does not build your intellect. It is just like this type, like this. This type, solve it like this. That's all. Hi Jacob, welcome. Let's solve the next question. Wire, this much resistance, this much series with this much external resistance, this much. Okay. Secondary cell is connected. Okay, first let's draw the primary. So we have a battery. Battery is how much? 15 volt. And wire length is given, series with this much, and external resistance. So there is an external resistance like this of 40 ohm. This whole thing is connected to our wire. This is point A, this is point B, this is your potentiometer wire. Okay, cool. Now a secondary cell of EMF E is connected in the secondary circuit, balanced at some other length. Okay, now this length is also given. I think that length is 10 meters. So that length is basically 10 meters. That is also given. Now you take another circuit. EMF is basically E. Okay, and you take one point, connect it here. Other point, remember, always via galvanometer, connect it at this point. This is 240 centimeters, which is nothing but 2.4 meters, of course. That is 2.4 meters. This is the question. Now you try to solve it. Simple. Guys, whatever voltage is there across AJ, whatever voltage is there across AJ is also the voltage across the cell, which is nothing but your EMF. Okay, and that's exactly the question. I don't know what is the voltage across AJ. It is nothing but the gradient into that X. It's the gradient, the rate at which the voltage drops into the length. Voltage drops so many volts per meter. So for this much length, how much does it drop by? That's all. Now, what do you do? Good evening, Sahiti Uddanandam. Gradient is nothing but the voltage across AB upon the length of AB. X, I will substitute it later. If you are wondering what X is this guy. This is basically X. Okay, fair enough. Okay, let's take care of it later on. Don't worry. Voltage across AB, well, it is not given. Maybe I need to find it. And how do I need to find it? Observe. It is clearly mentioned that the wire's resistance is 20 ohms. So the current in this circuit, there will be some current in this circuit which will be flowing. That current will be the total voltage divided by the total resistance of only that yellow part. Remember, these two circuits are different. Don't forget that. Total resistance is 40 plus 20. So 15 by 60 is 1 by 4 amperes. Now the voltage across AB is I into R. It's a resistor at the end of the day. So I into R, that's it. So current is 1 by 4, resistance is 20 ohms, so 20. So that's basically 5 volts, that's it. So just substitute everything over here and you will get the answer. So this is 5, the length is how much? 10 meters, just check this out, 10 meters. X is how much? 2.4, EMF, I do not know. So EMF will be 2.4 divided by 2, which is 1.2 volts. That's the final answer. Done. Option B, very good. You guys are very quick. Abhishek, I would suggest you start watching the playlist Pathfinder. Okay, you please start watching the Pathfinder playlist. It's very important. Silver, I stay in Bangalore. Please come to office. Anytime you guys come to Bangalore office or come to Bangalore and you want to meet me, please feel free to drop me, tag me. Usually I read messages, but there are good chances that I can miss the messages also. So you can tag me and you can say, hello sir, and tag a few more teachers, all the teachers of Vedantu. Sir, I'm coming to Vedantu office. One of the kids recently did that. I'll see you. Then I will pack my bags and I will make sure that I don't have lunch at home and all of that, and then I can probably also treat you. Yeah, please come hungry. Oh, now I'm pretty sure many people will come. Okay, let's move on to the next one. In a meter bridge experiment, null point is obtained at 20 centimeters from one end of the wire when the resistance X is balanced against some other resistance. X is less than Y, then where will be the new position of the null point from the same end if one decides to balance with some new resistance now? Okay, so let's try to do this. Again, I feel two situations, two diagrams, that's all. In a meter bridge experiment, meter bridge means Wheatstone at the end of the day. Okay, null point is obtained somewhere where X is balanced against Y. So X is balanced against Y. This is your potentiometer wire. This is your potentiometer wire. Okay, and this is your galvanometer, this is your balancing length, this is L1, this is L2. Cool. Now, according to the question, It is given that the initially balanced length is 20 centimeters. So this is 20 centimeters. Naturally, it's a meter bridge, 1 meter minus 20 centimeters. So basically the remaining length will be 80 centimeters. We all know x by y is L1 by L2. So it will be 20 by 80, which is nothing but 1 by 4. So y will be equal to 4 times of x. That's what I got. That's the first situation. Now let's think about the second situation. In the second situation, you are balancing 4x with y. Okay, so this resistance is 4x. You are balancing it with y for the same meter bridge. So the question is, what is the length? So let's just check this out. This is L1, this is L2. So 4x by y will be L1 divided by L2, Wheatstones Bridge. Hold on. 4x is just y. That's what I got over here. So how about putting it over here? So 4x is just y. So y by y is L1 by L2. So naturally L1 is L2. Therefore L1, L2 both are midpoints. So 50 centimeters. That's the answer. Done, done, done. CG, you missed a lot of fun today. Lot of fun. So many questions. Charan, practice, practice, practice. Just like in KGF. Your hero says, violence, violence, violence. I don't like it. But violence likes me. So same way, practice, practice, practice. If you don't like practice, practice will have to like you. That's when you will do the problems very easily. Okay, moving on. What do we have? A 5-volt battery with internal resistance of this much and a 2-volt battery with internal resistance of this much are connected to 10 ohm resistor as shown in the figure. The current in this resistor is how much? Let's try to do this question. Well. Oh, you know what this circuit is? I think I know. This circuit is actually, just turn it and just rearrange it. You will realize what it is. This is 10 ohm. This is 2 volts, 1 ohm. This is 5 volt and this is 2 ohm. No problem, CG. Master, I don't much confidence. Master Mask, I think you should start seeing many of my classes, many classes which are there over here on this channel. Please start watching the recordings, everything. Then you will get confidence. Watch the zero to hero, watch zero to superhero, everything. Let's try this out. What are these two in? These two batteries, what do you think they are in? They are in parallel. So it's cells in parallel. You can replace them with only one cell and one internal resistance. That's it, what you need to do. So 10 ohm. Oops. This 10 ohm. It's 10 ohms. And that's how you can find the current in the circuit. So use your formula. What's the formula? The formula is EMF in parallel is E1 by R1 plus E2 by R2 upon 1 by R1 plus 1 by R2. So start substituting. What is it? 2 by 1 plus 5 by 2 whole thing divided by 1 by 1 plus 1 by 2. So LCM is 2 obviously. So it will become 4 plus 5 divided by 2 divided by 2 plus 1 whole thing divided by 2. 2 cancels. So it will be 9 by 3 which is 3 volts. Fair enough. So this battery equivalent is 3 volts. We need to find RP now. So 1 by RP or just RP will be R1 R2 divided by R1 plus R2 because only 2 of them are there. So what are the resistors? 1 and 2. So 1 into 2 upon 1 plus 2 which is just 2 by 3 ohms. So this is nothing but 2 by 3 ohms. Fair enough. Great. Now the last thing that we need to do, well, I need to find out the current. So what is the current? So current is voltage by resistance. Voltage is 3. Resistance is 2 by 3. It's not 213 guys. It's 2 divided by So this is divided by 2 by 3 plus 10. So you can do the math now. So 3 goes on the top. So it will be 9 divided by 30 plus 2, which is 32. So current will be 9 divided by 32 amperes. That's all. Thank you, Sapna. Yes, my audition is done. Did any director see me? I don't know. But my students saw me. So sad. Okay, yes, 9 by 32 amperes. And it flows from P2 to P1, obviously. This battery and this battery both will supply the current like this, obviously. Done. Okay. So I hope this is clear, guys. Everyone? Okay, great. Now we will do more questions in the days to come, and I'll show you what you should do and from where you should do and how you should do. First of all, first link is the crash course link for JEE and NEET. The second important thing which you should keep yourself aware of is the playlist. Lots of playlists are there right here over in the channel. So like you can see, if you're even on the home, okay, so even on the home, you will see last minute revision 0 to hero flash series. All these are there. So let's say for physics, you can see this playlist. I'll make sure that this playlist is also updated. So these are your 0 to superhero series, which is being conducted this year for 2022 entrance tests. Amazing lectures, problem solving concepts, and also your formula revision. You can also see there are mock tests available over here. Separate playlist for mock tests. Dynamite problems are single problems which are very good. You can watch it right over here. If you go ahead, you will see last year 0 to hero problem solving series. It's very good. You should definitely check it out. And also the complete formula revision series is also right over here. Only formulas. Not many lectures are there, but that one lecture or two lectures will also be so good that all the formulas of all the chapters will be revised. So you can have a look at that as well. If you need detailed classes, then you have 12th and 11th standard classes here on YouTube. And then when you want to solve assignments, when you need that material, and when you the JEE playlist is also for NEET. Yes, both things, both people can use this. Yeah, it's for both, guys. It's not for JEE alone. It's for both NEET and JEE, everybody. You can see that there is a crash course link right over here. You can see that both the crash courses are in English. You can click on any one of them. You can see it's JEE Crash Course Lite. Language is English. All the subjects completed. You will get full classes, course offering, batch details, results, testimonials, the study material. Everything will be provided. And it is 5-week course. So you don't have time. You need to buy it right now. You cannot waste a lot of time. Because I am also teaching in the crash course. Other teachers are also there. Assignments are there. All India rank test series are also there. Recordings are available, notes are available, strategy sessions are also there, and complete guidance till you actually clear the exam. So all of this in the JEE as well as the NEET crash course right over here. Again, you can see it's just for 2,700 rupees. Same things. You have assignments, you have all the things that you would need interactively to learn for your NEET exam. So guys, make sure that you buckle up now. Okay, not many days are remaining. I would really want you to get into a very good college, a very good IIT or a very good AIMS, very good, government medical college or government college, whatever your aim is, whatever your ambition is. You need to buckle up, you need to push yourself, use these resources. I've shown you all the resources that are there on the channel as well as the platform. The combination works the best. Don't refrain. Don't think or doubt yourself. I have faith in you. You should also have faith in yourself, no matter what anybody says. Please buckle up. I'll be seeing you tomorrow for magnetism chapter. Okay. Sir, is mains or NEET tough according to difficulty level? Well, there were some papers of mains which were easier than NEET. So that's also a possibility. But usually JEE mains is slightly higher than NEET. Slightly. For physics. Okay, slightly, I would say. Okay. Is becoming a doctor or anything unique? I mean, is it so hyped up profession? Well, James Work, even, I used to think about the same thing. I can have, why did you remove the message? It's fine, you can ask it. Thank you, Nikita, Sriji. But it is definitely not hyped up because you are doing God's work and you need a lot of doctors. You need good doctors, and being a doctor or engineer or lawyer or any other profession, you need lot of hard work, lot of years of knowledge, lot of practice, lot of intelligence, lot of smart work. So that's why the entrances are also there. A lot of people also work for it. You also get good money if you are a very good doctor. Keeping money aside, you are doing good work, and you need that kind of brains to become a doctor or an engineer. Okay, so it's not exactly hyped up. It's just that it's easier. I won't say easier, but most of the people can easily become engineers and doctors if you have good intelligence, rather than becoming an artist, because not everybody can be an artist. Like, I can't become a singer, many people can't become a dancer, many people can't become actors, many people can't become painters or maybe poets or writers. God knows. The arts are also good, but you should be good at it, and there is a lot of struggle out there too. So, and you don't need many of them. You don't need lakhs of singers. Yeah, you have a couple of good singers who make names. So that's why, unless you are really good, it's very difficult to sustain in those industries. But yeah, they are very good, and if you are good at something, you should definitely pursue it. So doctors, it's not like there's only one best doctor. There are so many doctors, and you need, if you have a good doctor in Bangalore, you need a good doctor in Jammu Kashmir, you need a good doctor in Tamil Nadu, you need a good doctor in Andaman, you need it. It's not like, oh, this doctor is there, good, he's there in Bangalore, I don't need a doctor in Jammu Kashmir. No, you cannot say that. So that's how it is. So it's a service, James Bond, you have to dedicate your life. So it's not so easy. Yep. Do all the chapters will get confidence about physics? Yes, I'll be doing it. Most of them. I can't assure all, but most of it. Telegram, yes, I do post on Telegram about my lectures. So just 1 hour before the posting is done, you can check it out. Okay, that's it for tonight. Thank you very much. It was very cool, very amazing to interact and see that you guys learned a lot. Keep it up. See you tomorrow at 7 o'clock. Bye bye. Hasta la vista. This was Shreyas here.